Hello class, today we are going to talk about our medians and altitudes of triangles. All right. So first we'll talk about medians. What's a median? Well, a median's that thing in the highway that keeps people from running into, no. The median is, it is, but on a triangle. That's what we're looking for. We want the median of a triangle. Median of a triangle. It is a segment drawn from a vertex to the midpoint of the opposite side. Okay? So from the vertex to the midpoint. And the three medians of a triangle are concurrent, which if you remember, that means that the three medians intersect at the same point. And the point of concurrency, this point where all three of them come together, is called the centroid. Okay, this is the centroid of the triangle. Okay, so this is a third center. Remember, we've already had two centers. We had the incenter and the circumcenter. This is the centroid. Okay, so it's another center of the triangle. Three centers so far. So here in the picture, we have D, E, and F are the midpoints of their respective sides of the triangle, right? And we know that because the segments that around them are congruent. Those are congruent, those are congruent, those are congruent. So these are the midpoints. And so we have a line, or a segment drawn from the vertex to the midpoint, from the vertex to the opposite midpoint, from the vertex to the opposite midpoint. So these are your medians, and we see they all intersect right here at point P, which is the centroid of the triangle. Okay? Now, that's all well and good. We have some other stuff here. The centroid theorem. Okay? What the centroid theorem says is that the centroid of a triangle is always going to be 2/3 of the distance from each vertex to the midpoint. Okay? So what that means is point P is 2/3 of the distance from B to F. It is also 2/3 of the distance from C to D and 2/3 of the distance from A to E. So AP is 2/3 of AE. Okay? So I'm going to go ahead and put this on here. This is 2/3 from the vertex. The vertex side gets 2/3, which means how far is the midpoint side? Well, if this is 2/3, the midpoint side is going to be 1/3, which also means that in each case, this is 2/3 and that's 1/3. What's the relationship between AP and PE? Well, yeah, that's right. PE is 1/2 of AP. PF is 1/2 of PB, PD is 1/2 of PC. All right, and so that's other things. And so we can use that to find different lengths of these segments. Okay? Another cool thing about the centroid is the center of balance for the triangle. So if you had, like, for example, a triangular table, and you just wanted to put one leg right in the middle to hold it all up, the centroid is where you're going to want to put that leg so that everything balances. Okay, so that's kind of cool. So that's medians and centroids. Let's take a look at altitudes. Okay, so hopefully you remember what altitudes are. You've talked about these before in earlier classes. Altitude is the height, right? Now, this is more technical than that. So altitude is a perpendicular segment from a vertex to the line that contains the opposite side. All right, so here, the altitude is right here. Notice perpendicular to segment PR, right? Over here, though, in this triangle, the altitude is not even in the triangle. It is still this segment. It is perpendicular to, not to PR, to segment PR, but to line PR. So you have to extend this segment out, and it is perpendicular to the line that contains segment PR. Okay, so that's why the verbiage is like it is, because it's not necessarily going to be inside the triangle. Not necessarily going to be perpendicular to the side of the triangle, but it might be perpendicular to the line that it contains the side of the triangle. All right. Now, all of the altitudes are also concurrent. Okay, it means that they all come together at the same point, and for altitudes, that point where they all come together is called the orthocenter. All right. Okay, so all of the altitudes come together at the orthocenter. And right here, perpendicular, all these sides. Notice these are not perpendicular bisectors. Okay, they're just perpendicular and they go through the vertex. All right. Now, as we saw, the altitudes don't even have to be inside the triangle. And if the altitudes are not inside the triangle, that means the orthocenter also might not be inside the triangle. Okay, sometimes it will, sometimes it won't. So if it is an acute triangle, orthocenter is inside the triangle. If it is a right triangle, the orthocenter is on the triangle. And specifically, the orthocenter of a right triangle will always be the right angle. Okay, right here on the right angle of the triangle. Okay, so that makes it real easy to find. Obtuse triangle, nope, outside the triangle. All right. And it's a little bit hard to see. This is all black and white. So our triangles, I'm going to go ahead and put the triangles in blue. So here's the triangle, and the orthocenter is right there. Right triangle, a little easier to see because you only got the triangle there, right? Right triangle, and the orthocenter is right here. For an obtuse triangle, here's the triangle right here. And the orthocenter, notice only one of these altitudes even goes through the inside the triangle at all, and that's the altitude right here. And so all of them, though, come together right out there. And so you see, for the obtuse triangle, the orthocenter is not inside the triangle. All right. Okay, so that is all of the basic learning information stuff. Now we get into the application. How are we going to use this? How is this going to help us out? All right, so let's open this up. Let's take a look at a couple of problems here. So we are going to start by looking at the centroid. So on 1, 2, and 3, it tells us that point P is the centroid of triangle LMN, and we need to find the length of PN and the length of segment QP. Number one, we have QN. This entire thing has a length of 33. We need to find the length of QP and the length of PN. Well, if this is the centroid, as it says, that means that it is 2/3 of the distance from the vertex, right? That's what we have right here in the centroid theorem. The centroid is 2/3 of the distance from the vertex. So that means from the vertex, that is right here. So this is my 2/3 part. This is 2/3, this is 1/3, right? And so that means that PN is equal to 2/3 the length of QN. So that's 2/3 the length of 33. So the length of PN equals, let's see, 2/3 of 33. So 33 divided by 3 is 11 times 2 would be 22. So PN is 22. And now we need QP. Well, QP is going to be 1/3. Instead of 2/3, it's 1/3. So that would be QP is going to equal 33 times 1/3, or 1/3 of 33. So QP equals 1/3 of that would be divided by 3 is 11. And so there it is. Not bad. Also, another way we could have done this, as we said before, the midpoint side is half of the vertex side. So half of 22 is 11. Another way we could do it. All right. So let's take a look at number 2. Number 2, we have QN is 45. P is the midpoint. We want to find the length of PN. We want to find the length of QP. So this is the vertex side. So that is 2/3. So PN is equal to 2/3 times QN, which is 45. So PN equals, let's see, 45 divided by 3 is 15 times 2 is 30. There's PN. Now we need to find QP. Another way we could do this, well, the whole thing is 45 minus PN, so minus 30, right? Because this is 30. So this must be 15 for QP. Those are my answers. Going to put a box around those. So we'll put that there, 15. Not too bad. Let's take a look at number 3. Actually, you know what? Let's have you solve number 3. So pause the video, work out number 3, then come back and check your answers. All right, you are back. Let's see how you did. QN is 39 units from Q to N. So this is going to be 2/3. So PN, because that's the vertex side, equals 2/3 of 39. And so PN equals 39 divided by 30 is 13 times 2 is 26. And QP is going to be 26 divided by 2. So that means that QP is going to equal 13. So hopefully that's what you got for your answers, 13 and 26. All right, so that's not too bad. That's actually pretty easy stuff there. Let's take a look at number 4 and number 5. Here it tells us point D is the centroid, and we need to find the length of CD and the length of CE. Alright, so it gives us DE. So this time it's not giving you the length of the whole thing. This time it's only giving you the length of the midpoint side. So the midpoint side here is 7. So if this is 7, remember we said the whole thing, the vertex side is going to be twice the midpoint side. So CD is going to equal 7 times 2. So CD equals 14. And if this is 7 and that's 14, the whole thing, CE is going to equal 7 plus 14, and so CE equals 21. And that's also pretty easy stuff. How about you pause the video and let you work out number 5, because it's just as easy, and then come back and check your work. All right, let's see how you did. So DE is 12. Again, that is the midpoint side of this. So 12. The vertex side is going to be twice that. So DC is going to be 12 times 2. Well, sorry, CD. Same thing. So CD equals 24. 24. And if this is 1/3, that means the whole thing is 3/3. We can just take it times 3. That's another way we could do this. So CE is going to be 12 times 3, so CE is equal to 36. Or we could have done 12 plus 24, either way. All good. Always nice when you have multiple ways to do it. It gives you options. You pick one you like. All right, so there it is. Centroid, not hard. Easy stuff. Just remember it's 2/3 to the vertex. Now we're going to get to stuff that's slightly more complicated, because here what we're going to do is look at this on a coordinate grid. So looking at this on the coordinate plane, what it wants us to do is find the coordinates of a triangle with the given vertices. So let's take a look. It didn't give us any axes, so we need to draw those in. Let's see here. So A, B, and C, x's go from -2 to +4. I've got 10 dots, so that'll all fit in there. I can go by ones. Y's go from +4 to -4, so again, I can go up by 1. So I can put this in the middle, and that'll give me from +5 to -5, so I don't have to mess with my scale. Always have to check that. Sometimes you need to change your scale so you can make everything fit, but we got lucky. This time we don't, so it's good. All right, so there's my axis. I'm going up by 1s. Let's put our points in here. There's our triangle. We need to find the centroid. Remember, the centroid is the intersection of the medians. So where are the medians? Well, I don't see any medians. Medians, remember, is from a vertex to the midpoint of the opposite side. And a couple of ways we could do this. One, we could draw all of the medians, which would be annoying. Or two, we could draw one median and then find, because remember, the centroid is 2/3 of the distance from a vertex to the down along the median, right? Now, to do that, couple things. We could draw this one here. It's probably going to be at an angle, but that's going to be hard to find the distance, hard to find 2/3. We can do it because we know how to partition a line segment. We did that way back several lessons ago. Or what we can do is hope that one of our medians is going to be on a vertical or a horizontal, because then we can just count, and that's much easier. So let's see here. This one looks like the median's probably going to come over here somewhere, which would not be vertical or horizontal. B, coming from B, that might be. We'll have to check that one. That might work. This one is going to be come up here. That's definitely not vertical or horizontal. So what we're going to do, we need to find the midpoint between A and C. All right, so the midpoint from A to C, we'll call this point M, and we're going to use the midpoint formula. So if you remember the midpoint formula, you add up the x's, divide by 2, then you add up the y's and divide by 2. So our x's are -2 and 4. So -2 plus 4 divided by 2, and then the y's, -1 and -4. So -1 plus -4 divided by 2. All right. So that makes our midpoint is going to be -2 plus 4 is +2, divided by 2 is 1. And our y's, -1 plus -4 is -5, divided by 2 is -2.5. So that is our midpoint. So 1, -1, 2.5 is right here. And yes, indeedy, that is just what we wanted. Our median here is going to be a vertical line, which makes it nice and easy. Our centroid, which I guess we'll call point P, why not, is going to be 2/3 of the distance from the vertex to the midpoint, right? So we need to know how long is segment BM, and since it's vertical, all we have to do is count. So that'd be 1, 2, 3, 4, 5, 6.5, right? 1, 2, 3, 4, 5, 6.5. So segment BM is 6.5, and we need to put P somewhere on here. So we need to find out how far is it from point B to point P. So BP, remember, is going to be 2/3 times 6.5, and that is one I cannot do in my head, so I'm going to pull up my calculator. 4 1/3. Lovely. 4.3. So let's minimize that. 4.3. So that is the distance we want here. 4.3 is the length of BM. So that would be down 1, 2, 3, 4 1/3. Right there, which makes this at 1 and -1/3. And that's it. So point P is at 1 and -1/3. Not like wonderful, but not terrible, right? It's not the easiest thing we've ever done, but it's not bad. Definitely easier than some things. All right, so let's take a look at number 7. Let's go ahead and try number 7. Let's see here. I'm going to draw this in. Now again, remember, when we do this, we are hoping that we can find a median that is going to be either vertical or horizontal. Either one will be good. Let's see, looking at this, that's going to be somewhere over here from F. That's not going to work. D's not going to work, quite obviously. Coming from point E, that looks like it might work. Hopefully that's the median. It's the midpoint. It should be. Let's go ahead and check it. Always want to plug this in and check it. So let's see here. Midpoint from D to F, -5 plus -1, because remember you add your x's, divide by 2. And then the same thing for your y. So 4 plus 4. 4 plus 4 divided by 2. And this will give us point M, our midpoint here. So -5 plus 1 is -6. -6 divided by 2 is going, I don't know why it's blurring. -6 divided by 2 is -3. Then we have 4 plus 4 is 8, divided by 2 is 4. And so that puts it at -3, 4, which just what we wanted, because now we see that is vertical. Now we need 2/3 of the distance from the vertex. So we're going up. All right? So let's count it. 1, 2, 3, 4, 5, 6. So segment EM has a length of 6. We could do the distance formula, but it's vertical, so we don't have to do the distance formula. We just count. All right. And so EP is going to be 2/3 times 6, right? Because it's 2/3 the distance from the vertex. And so EP, 2/3 of 6 is 4. So 4 units from E. So we're going to go up 1, 2, 3, 4, puts point P right there, and we can see that is at point 1, 2, 3. Sorry, -3 and 2. Way you can check this, remember, is the midpoint side is going to be half the vertex side. So if this is 4, half that is 2. Over here we had that's a little bit more difficult because it's 4/3, but we need to check that. Now, this was lovely. There's a shortcut. Everybody likes shortcuts. This is not in the textbook. This was not in any textbook I ever had. This was not taught to me by any of my teachers. One of my students found this, and it works, so it's awesome. I'm going to teach it to you. All right, the centroid theorem, and we are going to write this on the front. Not the centroid theorem, the centroid formula. So point P is at x1 plus x2 plus x3 divided by 3. Then we do the same thing for the y's. y1 plus y2 plus y3 divided by 3. This gives you a centroid. Notice this is very similar to the midpoint formula. That's all it is. You take your x's, you average them together. You take your y's, you average them together. Just like you did with the midpoint formula, only you have a third point. All right? So let's take a look at this just so you see this. So this would be -2 plus 1, -1, plus 4 would be 3. Divided by 3, x is 1. -1 plus 4 is +3. Minus 4 is -1. Divided by 3 is -1/3. So that's cool, right? Now, what I want you to do, pause the video, work out number 8. Find the centroid. Now that you have your formula, you can do it without even graphing it. All right, you're back. I'm going to go ahead and graph this just because. Take a look at the midpoint theorem, or the midpoint formula, which I just gave you, and P is at 8 plus 20 plus 8 divided by 3. Then 7 plus 5 plus 3 divided by 3. So let's take a look at this. 8 plus 20 is 28, plus 8 more is 36. 36 divided by 3 is 12. 7 plus 5 is 12, plus 3 is 15. 15 divided by 3 is 5. That puts point P at 12, 5 right here. And our median be here from K through point P. We'll draw that one in there. That's point P. And just to check it, the distance here should be double that, right? So we're going by 2s. 2, 4, 6, 8. And here we have 2, 4. 8 is twice 4. So that works. All right. And this was so much easier than doing all of this work, wasn't it? Much easier. Centroid formula is lovely, and I wish I had been taught it in school. But one of my students found it. Always learn more from your students than they learn from you. It's awesome. All right, last two here. I know our video is running a little bit long, but that is okay because we're on our last two. Here, what we want to do is find the orthocenter. Is it going to be on the inside, the outside, or is it going to be on the triangle? That's what we want to do first. Where is it going to be? Inside, outside, or on the triangle? Then we're going to find the coordinates. All right. So let's take a look at number 9. Let's see, we've got to graph this in. And let's see, what kind of triangle do we have here? We have, well, this is a vertical line, that's a horizontal line, so those are perpendicular. This is a right triangle. So let's take a look at our instructions here. For a right triangle, the orthocenter is going to be on the triangle. And specifically, I told you it is going to be that right angle. So that makes it easy. Our answer, it is going to be on the triangle, and it's going to be the right angle. It's going to be this right angle right here. So that is our center. Let's see, we can't call it P up here. We'll call it C for orthocenter. C is going to be at 1, 0. That was easy. All right, let's take a look at 10. Number 10. So hopefully this will be a right triangle. That'll make it easy again. All right, but looking at this, not going to be a right triangle. So we're going to have to actually do some work on this, which is annoying, but that's okay. Now, first off, is it going to be on the inside, outside? It's not going to be on the triangle because it's not a right triangle. Well, let's see, what kind of triangle is this? This is an acute triangle. So take a look at this, acute triangle. The answer is going to be inside the triangle. So it's going to be inside somewhere. Where's it going to be? So let's take a look at this. We need to draw 2 of the altitudes. So we need 2 lines that are going from a vertex and that are perpendicular to the opposite side. Now, the easiest side to get perpendicular to would be side PQ. It's horizontal, so we need a vertical line that goes through point R. So that's going to be the easiest. That'll be right here. So we have a nice vertical line going all the way through there. Could just do it on the inside because it's acute, so we know it's going to be on the inside. But we're just going to draw it all the way through. We could draw all 3, right? But since all 3 are going to intersect at the same point, we just need 1 more. Because wherever 2 of them intersect, the third one will also intersect there. So we can either draw one coming from point Q, or we can draw it coming from point P. All right, so let's see. We'll go with this side here, because that's going to be the easiest to do, I think. So the slope here, the slope for segment QR is 3. We need a perpendicular slope, so we can have that altitude. It's got to be perpendicular. So whatever our center is, point C, somewhere over here. So segment coming from P through C, our slope is going to be the reciprocal of that, opposite reciprocal, so -1 over 3. So that's our slope coming from point C. So we're going to go down 1, right 1, 2, 3. Don't do it. Down 1, right 1, 2, 3. Right here, which is annoying. It looks like this is not going to be on the grid line, so this can take a little bit more work. All right, so our orthocenter is right here, which is going to make this a little bit more complicated to find because it's not actually on the grid line, right? So let's take a look. Got to figure out where these 2 intersect. It might be at the half, it might be at a third, I don't know. We're going to have to figure this out. Now, to do this, what we have to do is find the equation for both of these lines and then find the intersection with those equations. Well, this one's vertical, so that's easy enough. That is going to be x equals 7, all right, which is going to make this a little bit easier. So now we need the equation for this one. And what I would do on this, since I don't know the y-intercept, because it's also not on an intersection there, not on a point, is point slope form. I've got a point. I know this point. Point P is 2, 4. I know the slope, so I can do this in point slope form, which is y minus y1, 4, equals my slope, -1/3, times x minus x1, which is 2. Now I want to find out where this intersects with x equals 7. which is actually pretty easy. If I know x equals 7, I can take that 7 and plug it in for x, which is what I'm going to do. First, though, I want to get y by itself, so I'm going to move this 4 over there. So y equals negative 1/3 times x minus 2 plus 4. I'm going to plug a 7 in right there. Y equals negative 1/3 times 7 minus 2 plus 4. And I'm just going to stick this in the calculator because I'm feeling lazy right now. Move that over so I can see what I'm doing. And I have negative 1/3 times 7 minus 2 plus 4. And it equals 2 1/3. So y equals 2 1/3. X is 7. So my center there is going to be at x of 7, y of 2 1/3. Like that. So that one is a bit more complicated, but that is as complicated as it will ever get, pretty much. So it takes a little bit more work when you have to calculate the intersection because it's not right on a point. It's not on the, like that. But it's not terrible. It's not too bad to do. Important things to remember. Centroid is the intersection of medians, which go from a vertex to a midpoint, and the centroid is 2/3 of the distance from the vertex. Very important, 2/3 of the distance from the vertex. Centroid will also always be inside the triangle. Altitudes are perpendicular from a vertex, and they come together to form the orthocenter, which is not always on the inside. All right. Also, don't forget, centroid formula makes things nice and easy. So that is altitudes and medians, medians and altitudes, orthocenters and centroids. Hope you found that useful. I know it ran a little bit long this time. I do apologize. I'll try to keep them shorter in the future, and I hope to see you then.